This video is recorded to help my students to understand three concepts and put them together. First, how to write a class. Second, how to write a linked list, basic functions. Third, how to do the separation compilation. That means you write header file, implementation file, and application file put together as a project. So the problem we will solve is the problem we solved before. Before we use fixed size array, this time we will use linked list. The problem is create a program to help a school to manage its student information. For simplicity, we assume that a student information include student's ID, name, and GPA. Of course, in the real world, probably should include more information like a student home address, social security number, email, phone number, all those things, right? The program has the following requirements. First, she'll be able to add, delete, and search for a student. When you search for a student, search by ID. You delete a student, you also give a student ID, then delete the student from the system. Add a student, of course, you need to have all information. You need to have student name, ID, and GPA in order to add the student to the system. Also, she'll be able to output all students' information. And we have done this by using fixed size array. Now we use linked list to do so. Okay, so first we need to design the program. So we need to design the data structure. First, let's say the header file. The header file, you will say include a student H. If not define student H, then you define student H, then end if. All your declarations put in between this. So we still include the IO stream and the string class and using namespace std because some definition we need used. So first we declare student class. Student class, for simplicity, for the get and set methods, we only implement get ID method. Now, when you declare student class, design it, you say what will be the private attributes according to the requirement for this program. The student should know his ID, should know his name, and should know his or her GPA. Okay. Then we also have friend operators. We implement this input operator and output operator. Those are binary operators. Have a I stream and a student object. Here is a O stream and a student object. So the first one will overload this operator. Student information will be input as parentheses, then ID, comma, with no space, then name, comma, then GPA. Okay. Then the output operator will output student information as ID, comma, space, name, comma, space, GPA. Okay. So then the constructor, you have student default constructor, no argument. Another constructor gives three arguments, initialize three private attributes, which are student ID, name, and GPA. Then we only have one get method, get ID. This is the one we need for this program. Of course, in the reality, you must have all those get methods and set methods. You might have other member functions, but for simplicity of this program, we just implement the get ID method. Notice this method is constant, which means this method shall not change the private attributes of the student class. Okay, this is the student class. Then if we want to put a student object in a linked list, then we need to have a student node. So each node should contain the data, just like your project 5. The linked list is a linked list of integers, so its data is an integer, right? So for those program, the linked list, his data type is the student. So that means the data contained is a student. Then you need to have a student node which point to the next student. Student node point to the next student in the linked list. So this is the structure of student node. Now, if you recall in your project 5, you will have integer data here, right? Of course, you can change this as student data. Well, I use student s. Okay, the variable name is really doesn't matter. So then I will have some method to manipulate this linked list. First method is output student. This is supposed to be able to print out all the students in the linked list that pointed by head PTR. So head PTR pointed to the first student in load in this linked list. Then you should have a method called search student. If you give me a linked list of students, student node, then give a student ID, I will be able to search through this linked list, then return a student node point to the node contain the students that whose ID is the given ID. Also, I should have a method called add student. You give me a linked list pointed by head PTR, and you give me a student to add, then I will use this given student to create a student node, then add this node to this linked list. If I do so successfully, return true, otherwise return false. When it's not successful, if the student you want to add, his ID already exists in this linked list, that means you already have this student in the system, so you don't add it anymore. Also pay attention, the parameter for this linked list is passed by reference. You notice this rotation, which means passed by reference. This means your head PTR might be changed. The reason I want to do so is every time I add a student, I don't want to add it to the end of the linked list. Why? Because that's have too much running time. I need to step through to the end of the list, then add the student. I normally add a student in front of the list. So in that case, the head PTR should point to the new added student node. Okay, that's why the head PTR value will be changed. Then this delete student. Delete student, again, you give a student ID here, then I will search through the linked list, find the student node that contain a student whose ID matches this given ID. If I can find one, then I will remove that student node. If not, then nothing changed. So if you successfully remove one, you return true, otherwise return false. Then I will have a menu function which display the menu. So that is all my header file. Now, let's say the implementation file, which I implemented this header file. So of course, the menu function is always the most simple one, right? I just simply display all the functionality I wanted to have. I will be able to add a student, delete a student, search a student, then display all student, then quit the program. That's my menu. Now, then for the student class implementation, also simple. If it's a default constructor, I just say ID equals 0, name is equal no name yet, GPA equals 0.0. Okay. Then for the constructor with 3 arguments, I will say ID equal given ID, name equal given name, GPA equal given GPA. You notice I declared the private attributes ID, name, GPA with underscore in front of it in purpose. The reason is the 3 argument constructor. Normally, in order to make it readable, you really want to say one argument name just call ID, name, and GPA. If your private attributes is exactly ID, then you will say ID equal ID. That's really confused, cannot do, right? So that's why I make a private attributes ID is underscore ID. The next member function is get ID. Well, I simply just return the student's ID. Okay. Next is the operator for input. You give me a stream and give me a student object. Notice this is also passed by reference. That means this input operator should be able to change the private data in S. Notice this friend operator. So we'll be able to access student private data directly use dot operator. So since the input format is open parenthesis, then ID, then name, then comma, then name, then comma, then GPA, then close parentheses. So I want to make sure this input is in the right format. If it's not, I will exit the program. So we do not handle the exception like your input is wrong, I give you another chance. For simplicity, we just say if your input format is wrong, I exit the program. So declare char. So I first read a char, which equivalent to read the open parenthesis. If this char is not open parenthesis, that means you have a wrong format of input. Then I will exit the program. Then I will read the s dot underscore id. That means I will next one is the student ID. Read, I will read it. Then after that, I will read a comma. So equivalent, I read a char. That comma is assigned to this char. If this char is not a comma, then I will say run format of input, exit the program. Then I will get the line of the student name. Now I use get line, but the delimiter is comma. That means I read the whole line until I meet first comma. Okay. Then that string I read, I assign it to the student name. Okay. Now, then I will say in s.gpa. That means I assume you have a comma as delimiter. Then I read a double value. Then I will read a char again, which is the close parenthesis. If this char is not equal close parenthesis, I also say it's wrong format of input, exit the program. Okay, so this is the overloaded operator for the input. Now the operator for the output, again, I will just simply output the close parenthesis first, then output the student ID, then comma space, then student name, comma space, then output student GPA, then output the close parenthesis. Okay. Now, if I want to output all the students in this student linked list pointed by the students, right? Then what I do, you also can change this to hide PTR if you feel like you wanted to do so. So as long as this student, which is the student node pointer, is not allowed, that means you still have some node to print. What I'm going to do, I will print out this node data, which is a student S. I will print out the students S. Notice that since students is a pointer, student node pointer, so to access his data S, you will use the arrow to recall what is this. You recall the student load structure. His one field is student S. That means this S is a student, so I will print out this student. Now notice I already overloaded the output operator for student, right? So this will print out a student, okay? So print out the information of student S in student node pointed by students. Okay, that's what this guy will do. Okay, then I print out a new line. Then I make my students point to the next student node in this linked list. So the loop condition is as long as the student not pointed to the now, that means you didn't go through the whole linked list yet. Each time I print out one student in the load that pointed by students. Then I move students pointer to the next node. Okay, that's print out all the student. Now, how about a search student? I want to search the student in the linked list pointed by header PTR. Okay, and the student by given ID. Now, in this case, I will step through the list. If found a match, return the reference to that student node. So as long as the header PTR not equal now, okay? If header PTR has student field, which is a student, that get ID called the student class method get ID will get the student ID. If that student ID double equal the given ID, that means you found it. Then you return this header PTR. If not return, then you move that header PTR pointer to the next node in the linked list. Notice I can change head PTR's value. Will not affect original linked list you pass to this method. The reason is you pass by value. That means this head PTR copy the head PTR of the linked list you pass to it. So you change this value of the copy will not affect the original one. Okay, so this will make your basically again this is like you step through the list. If you found a student node, his data, which is a student, get his ID equal the match ID, then you return the reference to that student node. If you step through the whole student node linked list, you did not find a match, then you will return null, which means you didn't find. Now add a student. Add a student method is just similar to the list head insert in your project 5. That means you want to insert a new node to the head of the list. Okay? So the idea to do this is I first search this list you gave to me with the given ID, with the ID of this given student. So I try to say if this student already in the linked list or not. If this search result not equal null, that means the student already in the linked list. Or in the application, your student already in your school system, whatever. Then you will return false. That means you do nothing, just simply return. Okay. Now, if the student node, if you found you did not return false, that means you did not find this student in the linked list. So you need to add this student in the linked list. Pay attention, you do not add a student directly in the linked list. You need make a student node. Use this student as the field of this student node. Okay? Then you add this student node to the linked list. So I need to declare a student node point called added node first equal new student node. This is allocated memory. Right? Then you let this student added node his student, which is one of his field, equal this added student. Then you make a copy of this added student to this storing this student load, which is added load. Then you let added load his next field point to the head PTR. That means this added load become the new head of this linked list. That's why you add in front of the linked list. Now, since this new added load, student node become the new head, that's why you need to update your head PTR equal added load. Notice this method you pass by reference, so you change the head PTR his value equivalent you change original student node linked list his head PTR. Why? Because you already added a new node contain this student you wanted to add to. In that new node, add it into the linked list. Then you will return true. Okay? So this is add student. Now, if you want to delete student, this method is a little bit more complicated. Now, in order to delete a student, of course, I need to load this student linked list I want to delete from. Then I need to load the student ID. Now, first, I check the special case. If list is empty, that means nothing to delete because you even don't have student, right? So I just simply say if the list, if the head PTR equal null, I return false. That means this linked list is empty. I just simply do nothing, return false. That means the deletion is not successful. Now, if not return, that means your list at least contain one student node inside. At least contain one student, right? So in this case, what I'm going to do, I will still divide it in two cases. One case is if the student you want to remove is the first guy, okay? If it's the first guy, equivalent I will do list head remove. So if the head PTR his student, the head PTR which is a pointer to a student node. If this header PTR, his student get ID equal to match equal to given ID, that means the first student in the linked list, his ID matches the given ID. In that case, I declare local variable called is a student node pointer called to be removed. To be removed equal header PTR. That means I want to move the first load. Now, since after you remove the first load, you have to up the second load in the original linked list become the first load. So you have to update the header PTR point to the original linked list, his next load, which means call header PTR his next load. Okay? Notice header PTR also passed by reference. That's why you can update his value. Now, after this statement, equivalently, now your header PTR point to original linked list's second load. But you want to remove the original first load, which is pointed by to be removed. Then you need a delete to be removed. Then you return true. Okay? Now, if you still don't return, which means the student you want to remove is not in the first load of the linked list. In this case, what we did do, this equivalency, same thing as your project 5, list remove. This time, in order to remove the load you wanted to remove, you need to load the load in front of him. Why? Because you need a you cannot just simply remove it, then your linked list will be broken. You need to find the guy in front of him, then the in front guy need to update his link to the next of the guy you wanted to remove. So in this case, I will declare local variable called student node point previous. Now previous equal header PTR, then equal as long as the previous his next not equal now, that means the previous still have next guy. Now then I will check if the previous his next his student, you find his next guy student his ID match the given ID or not. If not match, then you will say the next guy is not the one I want to remove. So I've updated the previous to his next guy. Okay. Now, if it match, that means the next guy is the guy I want to remove. Then what I will do, I will say to be removed equal previous next guy. The next guy I want to remove. After I remove, I don't want my linked list broken. So I want now, since the next guy will remove, so previous the new next guy is to be moved the guy his next guy. Okay, this statement keep linked list still linked. Since I want to move previous his next guy, right? So I want now the previous his next guy is supposed to be the guy to be moved the next guy. Okay, then I delete to be removed, then return true. Now if you still don't return true, which means what? Which means you did not find the guy you wanted to remove in your linked list. Then you simply return false. Okay? So after those, let us say, how do you apply those data structure? So let's say the main function. The main function logic is also very simple. Of course, I first have all this including, notice you need to include the student.h, right? Then in the main function, I declare some local variables. I need to have student node point students and an index, which is return. If you return me a load, student node, I need to have a reference to hold it. Then I have a student reference S. Okay. Then I have student ID. Then I have integer choice. Then I use do while loop. This do while loop as long as user's choice is not 5, which is a quit program. Okay. So I first display menu. Then ask a user to enter the choice from the menu. Then you get a user's choice. Then you switch user's choice. Case 1, you want to add a student. Case 2, you want to delete a student. Case 3, you want to search for a student. Then case 4, you want to display all students' information. Then case 5, you want to quit the program. Default, you should print out a message. No such option in the menu. Please choose from 1 to 5, which is your options. Okay. Now, then you begin implement the case one by one. Since case 1, you want to add a student. In order to add a student, I first create a student first. Okay. Now, after, notice you created this student by call the default constructor, which means the student name, ID is 0, name is no name yet, GPA is 0. That's not what you want. So you will prompt the information, say, enter the student information in the format, close parenthesis, ID, open parenthesis, ID, comma, name, comma, GPA, close parenthesis. You ask people to do that. Since you already overload this input operator, so you can just simply input this student. After input the student, you call the method add the student as to this student linked list, which is student node point students, right? You call the method add student. We already implemented this method. So this method will return you true if the student added successfully, return you false otherwise. So you will say the student has been added to the class. Okay? Now else you will say the student already in the class, no action taken. That's add student. Delete student is the same thing, similar thing. You first prompt a message into the student ID you want to delete. Okay? So you get a student ID, then you call the delete student method, which you pass a linked list of students load to it and the ID. This method will search through the linked list, find if any student in the linked list, his ID match the given ID. If you found one, then we'll remove that student node from the linked list. Equivalent, you delete the student. Okay, then print out the message, student has been removed from the class. Else, you will say no such a student in the class, no action taken. You also can search for a student. Search the student's ID, you into the student ID you want to search, you get the ID. Then you call the search student method. This will return you a reference that refer to the student you wanted to refer to the student node that you wanted to remove. So notice the index is a student node point. Okay, so you remove from the student node linked list. If this index equal null, that means you did not find the student. You say, oh, it's not a remove. I'm sorry, I say something wrong. It's return a reference to the student node whose student ID match this given ID. So if this reference is null, that means you don't have a student in this class. Else you will print out those student information because you found it, right? So we just simply print out the student information to check if our search method work. So how to print out the student information? Since the index is a student node point, so you just use index his student field, which is S. Then you, since overload the operator to print out the student, you just call it to print. Now, if you want the option 4 is display all student information, you simply just call the output student. You give the linked list of student node to it, he will print out all the students' information stored in this linked list. Okay, so let us test run this program. If I run it, will be successfully. Then go up. I say 1, add a student in the format. So I will say, suppose the student ID is 1000. First student is Tom Cruise. Suppose he is a good student. Well, maybe not that good, 3.5. Actually still good, right? So now you say the student has been added to the class. Now if you want to display all students, you just type 4. Then you say you will display 1000 Tom Cruise 3.5. Now suppose I want to add another student. His student ID is 1001 and Michael Jackson. Suppose he is a very good student, 4.0, right? So if you do that, he says the student has been added to the class. Then if you type 4, then you will say, now notice he added to the head because that's have better running time. We already explained that. Now suppose I want to add one more student. His ID is 1002, and the student name CS.Math.Educator. I'm okay student 3.8. So then say add to the class. Now let's try. I try to add a student ID with 1000 again. We know it's already existing student. Should I be able to add successfully? Then say student ID is 1000. Okay. Then I want which is Tom Cruise 3.5. Then here say student already in class, no action taken. Now, if I print out all the students, I should have only 3 students information. You see, there's 3 students here. Now, let us test search student. So if I want to search, he asks you enter student ID. Suppose I want to search student ID with 1001. Then he say 1001 is Michael Jackson. The GPA is 4. Okay. Now let's try to search someone not there. Search student. ID is 1003. Then you will say no such a student in the class. Now suppose I want to delete a student. If I type 2, then 1001. Suppose I want to delete a student. Okay. I choose the middle one to delete because you can see if it works. But I will go through delete one by one, delete all. When you test the delete, you might want to delete all to see if it works. Okay. I choose for middle one to remove first. Then he say the student has been removed from the class. Then display the student. Then you say that student not exist anymore. Then I choose delete student again, 1000. Then in display the student. You say I only have 1 student left. Then I choose to remove a student again, 1002. Now the student have been removed. Now I display all students. You say nothing displayed. Okay, so that means our program worked very well. I will post these files on Blackboard so students can download and study these files. The best practice is you watch the video, then try to spend the time to write this program by yourself. Okay, if you have any questions, please give me an email.